Hey, welcome back to our intro to trig. We're going to look now at actually writing the ratios. Now that you guys have practiced with opposite, adjacent, hypotenuse, and understand the vocabulary, we're going to use it to write our ratios. So again, I put this chart here that reminds you that sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent, and then a reminder of that SOHCAHTOA that helps us memorize that. Okay, let's just try a few together. So I have a triangle down here, and I'm going to identify the ratio for sine of theta, cosine of theta, and tangent of theta. To get started, I'm going to go ahead and write which side is the opposite, the adjacent, and the hypotenuse from my triangle. So the easiest for me to figure out first is the one opposite the 90-degree angle. That's going to be my hypotenuse. And then these are all in reference to theta. So the side that is across from theta is going to be my opposite. And the side next to theta is going to be my adjacent. So I would encourage you to get a piece of paper, draw this, and label them until you get really familiar with it. As we're learning, write it down, label it, so that you aren't confused. All right, so identify the ratio for sine. So sine, I'm going to use SO from SOHCAHTOA. All right, so I'm going to write this ratio, sine of theta, and I'm using this right here as my guide, equals, and then my ratio is opposite over hypotenuse. Well, which side did I say the opposite was? 5. Over the hypotenuse is 8.6. That is my ratio. And you read it, sine of theta equals 5 over 8.6. Okay, let's do it now for cosine of theta. So cosine of theta, I will use the K from SOHCAHTOA. So this is telling me that I want cosine of theta equals, the C stands for cosine, A stands for adjacent, which we identified as 7. The H is the hypotenuse, which we identified as 8.6. So you would read that, the cosine of theta is 7 over 8.6. All right, and then tangent, I'm going to use the TOA from SOHCAHTOA. T stands for tangent, so tangent of theta equals, O is opposite, which we said was 5, over A is adjacent, which we said was 7. So tangent of theta equals 5 over 7. Okay, let's do another one. So exact same thing, just doing it again for more practice. So SOHCAHTOA is going to help me. So for sine, I'm going to use SO. Before I start, I'm going to write down which is the adjacent, which is the opposite, which is the hypotenuse. So here's my right angle. And I just forgot to put the little right angle symbol on there. Across from it is my hypotenuse. Here is my sine of theta. Here's the angle that I'm referencing. So across from it is my opposite side. And next to it is my adjacent side. Hang on, that's messy. Let me try again. Adjacent side. All right, so for sine, or I'm going to use SO from SOHCAHTOA. So S stands for sine, so sine of theta equals, O stands for opposite, and H stands for hypotenuse. So opposite over hypotenuse. Opposite we already identified as 12. Hypotenuse we said was 30. So sine of theta equals 12 over 30. All right, let's do the same thing for cosine. Cosine, I'm going to use ca from SOHCAHTOA. The C is for cosine. A is the adjacent, and H is the hypotenuse. So cosine is adjacent over hypotenuse. Adjacent, we said, was 27.5, and the hypotenuse is 30. And then last for this one, the ratio for tangent, I'm going to use TOA. So the T stands for tangent. So tangent of theta is, O is opposite, A is adjacent. So the opposite we said was 12, and the adjacent we said was 27.5. So those are my three ratios for this triangle. Okay, now let's do it using an angle instead of theta. So sometimes the triangle will just be labeled ABC, and they will refer to the angle that they want by the letter at that angle. And we talked about that at the beginning of the year, how to name angles, but it's been a while, so just as a reminder. All right, so all of these are in terms of angle A. So all of them are in reference to this angle. So which side is my hypotenuse? The 12, the 9, or the 15? Well, the hypotenuse is always across from the right angle. So this is the hypotenuse regardless of whether I'm referencing A or C. Since I am referencing A, the opposite is going to be 12, and the adjacent is going to be 9. So again, I'm going to use my SOHCAHTOA. So for sine, I use SO. So the S stands for sine of A, which is already there for me. And then opposite over hypotenuse. The ratio of opposite over hypotenuse. Opposite we said was 12. Hypotenuse, 15. All right, then cosine of A. So for cosine, I'm using ca from SOHCAHTOA. The C stands for cosine, which it's already typed there for me. Cosine of A is adjacent over hypotenuse. So the adjacent we said was 9, and the hypotenuse is 15. And then last for tangent, I'm going to use TOA from SOHCAHTOA. T is tangent, A is opposite, O is opposite, A is adjacent. So opposite over adjacent. So opposite is 12 and adjacent is 9. So there are my three ratios for sine, cosine, and tangent for this particular triangle. All right, let's do another one. All right, I'm going to do it now from angle C. So I want sine, cosine, and tangent ratios, but from angle C. So this is going to still have my hypotenuse across from the right angle. This time my opposite is going to be 15 because it's now across from my angle C. And 20 will be my adjacent side because that is the side adjacent to angle C. So for sine, I use SO, which is sine opposite over hypotenuse. Opposite is 15, hypotenuse is 25. Cosine, ca. The C stands for cosine, the A for adjacent, H for hypotenuse. So adjacent is 20, hypotenuse is 25. And then tangent, I'm using TOA from SOHCAHTOA. T for tangent, O is opposite, A is adjacent. So opposite over adjacent would be 15 over 20. Those are my ratios. Okay, I'm going to skip that one because it's just like it. Let's do this one where I actually give you an angle measure. And the X, or the missing side, is going to be a length on the triangle. These ratios are exactly the same. I've just changed that we're looking for the side of a triangle instead of looking for an angle. The ratios are still the same though. So let's talk through this one. So sine of 73, all of these are in reference to this angle, angle 73. So across from the right angle, 25 is my hypotenuse. Across from 73 degrees is my opposite side. And next to 73 degrees is going to be my adjacent side. So this opposite, adjacent, hypotenuse are what I'm going to use for my ratios. So sine is so it is opposite over hypotenuse. So from 73, the side opposite is X, and the hypotenuse is 25. So that's how I would set up the ratio for sine for this triangle. Now let's do cosine. Cosine is CA from SOHCAHTOA. The C is cosine, which I already have that typed in for you. Cosine of 73 is adjacent over hypotenuse. So adjacent is 7, and the hypotenuse is 25. And then tangent. I'm using TOA from SOHCAHTOA. T stands for tangent. Tangent of 73 is already there. Opposite over adjacent. So opposite is X over adjacent, which is 7. That is my ratio. Okay, let's do one more. So SOHCAHTOA. This time I'm referencing this 25-degree angle. All of my ratios have sine of 25, cosine of 25, tangent of 25. So all in reference to this angle. So my hypotenuse is across from the 90 degrees, it's 65. The side opposite of 25 degrees is 33. And the side adjacent is next to it, which in this case is X. So SOHCAHTOA. So stands for sine opposite over hypotenuse. Opposite is 33. Hypotenuse is 65. Cosine, I'm going to use CA. So cosine is adjacent over hypotenuse. The adjacent side is X. The hypotenuse is 65. Tangent is TOA. Tangent, opposite over adjacent. The side opposite is 33, and adjacent is X. So there are my ratios. All right, you guys are going to go try the Google Form 4.3b now and identify these ratios. Again, I'm going to have a Zoom link open. If you get stuck, you have any questions, you work through it and you miss some, anything, click that Zoom link and I will answer it and we can just talk. All right, see you guys soon.